How we doing, guys? Just looking at Text and Test, chapter 4.1. Text and Test 4, chapter 4.1. This is page 112, 113. We're going to look at questions 3, 6, and question 8 as well. Sorry about that. So this is coordinate geometry of the circle. So if you have a circle, like this one that I've drawn here, that has center 0, 0, well, one of the defining characteristics is its radius. So if I want to see the radius, I can just say, well, there it is there. It's 1, 2, 3, 4, 5 units. So our radius in this question is 5. Here's one of the coordinates that you'll find on that circle. If you just draw it out, you'll find that 3 minus 4 is on it. The reason you'll find that is because if you go across 3 and down 4, you get yourself a right angle triangle of sides 3, 4, and if you do Pythagoras on that, you'll find that the radius comes out as 5. And Pythagoras is what defines all of these positions on a circle. That for a circle of radius r, you find that that's the x coordinate. You find that x squared plus the y coordinate, y squared, will always give whatever the radius is squared. So that is the equation of a circle that has center at 0, 0, and that's what we're working with today. Question 3 asks us, find the equation of the circle with center 0, 0, which passes through the point minus 4, 1. Okay, so, sorry, that's not the radius, that's the point. So we need to say, first of all, well, what's the distance between those 2 points? Okay, because that is going to be the radius of our circle. Okay, so, well, the distance is going to be the square root of minus 4 minus 0 squared plus 1 minus 0 squared. Okay, and that's going to be root 17, which means the equation of the circle with radius root 17, radius squared is going to be 17, so it's going to be x squared plus y squared equals root 17 squared, or 17. Okay, x squared plus y squared equals 17 is the answer there. Question 6, part 4 is working the other way. Write down the radius of each of these circles. So for this one, you can see 9 is 3 squared, the radius is 3. 1 squared, the radius is 1. The square root of 27, which you can write as 3 root 3, but it's there. You might think the radius here is 5 for part 4, but that's not the case because we don't have our x squared plus y squared form that we need to have. So we'll divide through by 4 to get that. You'll always have the same number, the same coefficient in front of x squared and y squared. If you don't, it's not a circle. So dividing through by 4 gives us x squared plus y squared is 25 over 4, which can be written as 5 over 2 squared. So the question is, find the radius of this circle. The radius is 5 over 2, or 2.5. Lastly, question 8, find the equation of the circle with center 0, 0 if the line 4x minus 3y minus 25 is a tangent. Well, here's the line 4x minus 3y minus 25. That's a tangent to our circle with center 0, 0. So really what we want to know is, well, what's the radius of the circle? So we've got a theorem that says that the perpendicular distance, that if you have a circle, the radius of that circle and the radius, and the tangent line to it at the point where that radius meets, okay, I maybe haven't drawn that perfectly, maybe it's up here, okay, but that these two lines are going to be perpendicular. Okay, so that's just always the case. Anytime you have a circle, a tangent is a point that just, as a line that crosses or touches the circle just once. Well, a tangent and a radius will always be at 90 degrees to each other. So that distance that I have marked in the diagram, the radius of the circle, is also the perpendicular distance from this line to our point 0, 0. Okay, so perpendicular distance formula, I can plug in 0, 0, and I'm going to get the absolute value of minus 25 over 5, which is 5. So 5 is the radius of this circle, which means its equation is x squared plus y squared equals 5 squared, or equals 25. Okay, so those are the questions. I'm going to ask you now, please, to go and do on page 112. Can you do questions 1 and 2, please? And tomorrow in class, we're going to finish the exercise. Okay, see you next time. Bye-bye.